Okay, so let us solve these differential equations using the Laplace transforms. Okay, let me put some dash here to separate the equations from the solutions. Okay, let's start. Okay, so let's do our first one. So the first one is y prime minus y equal to 0. This is the problem that we have given. So when you're solving using the Laplace transform, you basically do four main things. The first thing that you must do here, you must find the Laplace transform of all the terms that you have in your equation. So that's what you do. Basically find the, let me say, LT for the Laplace transform of all the terms. Number two, what you'll do is you have to apply the initial conditions. Apply the initial conditions. Number three, so when finding the Laplace transform of all the terms, what you will get here, you will get a Laplace of y, which will be sitting in just the Laplace transform as you are trying to find the Laplace transform of all the terms in your problem. So this, in number 3, you must make it subject of the equation. Okay, make subject of the equation. Let me raise here. Make subject. Let me make it short. Subject of the equation. Okay, subject of. Okay, subject of the equation. Then after this, the last thing that you must do, you must find the inverse. Find the inverse of the Laplace transforms. Okay, so finding the inverse of the Laplace transform will give you the actual y that you are looking for, which is a solution to the problem we are solving. So find the inverse. Let me just say find the inverse here. So inverse will then give you your y. That y is equal to, then you have to find the inverse of the right hand side. So depending on the problem that you are solving, then this question mark will be what you get according to the problem that you are solving, what you get on the right hand side. Okay, so let us try to just perform these 4 steps in solving these problems and see what are the solutions here. Okay, so we start the first one. You have to find the Laplace of this derivative. First derivative here. And then it's just the y equal to 0. The Laplace of the first derivative is simply just I will use a p. Some books they use a s. I'll use a p here. Okay, so if also you may, let me use y bar. Y bar is the Laplace of y. Okay, just it's easy and quick to write it in this way. Okay, so therefore it's a minus, then y naught minus the Laplace of y, again if we may, let us use a y bar, so equal to 0. So this is the first step in these 4 steps that I had here. So this is the first, which is where we are finding the Laplace transform of all the terms. Step number 2, if you recall, it says apply the initial condition. So therefore, let's go ahead and do that. P y bar minus y naught is equal to 2 according to the conditions given, equal to 0. Step number 3, we said to make this Laplace of y subject of the equation, so which is this y bar. So having two of these ones, so we must make this subject of the equation. So when we do that, so we are getting y bar. So p minus 1 is common in these two terms. All the terms without this y bar, we must throw them to the right hand side. Okay, so we transpose. So this is equal to 2. Okay. Make some space. Making subject of the equation, so it means we want it to be standing alone on the left hand side here. Therefore, we're getting a p minus 1 on the right hand side. Then lastly, step number 4, we must find the inverse here to get the actual value of y. It therefore means y is equal to inverse, right hand side we put it in. 2 is just a constant, you can even put it outside behind this inverse operator here. Okay. Then finally we get the answer. So the answer will be e raised to, since it's a function of time, so it's a 2e raised to t. Okay. Okay, so this is the answer to this problem. So the e raised to t, we are getting it from the formula e raised to at. The answer here is 1 over p minus a. Basically put the opposite of the signs, put a minus here. So if it's obvious it's a minus, therefore it's a plus here. The first derivative, the Laplace of this first derivative that we use here. Okay, if I may use a color. Right. So this one, we are getting this from a formula also. Since we are using p, I'll then say the Laplace of, let me say, nth derivative here. The Laplace of nth derivative is equal to p raised to n. These powers on top here, they must be the same. Then I'll use a y bar again. It's a minus. This power will drop by units. So therefore he means here it will be n minus 1. Have y naught minus 2. Then you start to see the derivatives now. They are all at 0. And then the formula continues. It continues like that. Up to, so it's up to, it's a minus. I'm going to write just the two last terms. So the very last term will be y n minus 1 at 0. Here means we're having y. We make a space. You're having y n minus 2 here. Then a p. Let me just say raised to a unit. Okay, so it is like this. All the signs are minus in between. It's something also you can get from a formula. Okay, so that is the answer for the first. Let's go ahead and do the second problem. Or else, in fact, let me erase so that we are close to these questions. So problem number 2, y prime prime minus 3y prime, so it's a plus 2y e raised to 3t. Okay, so that means you have to find the Laplace transform of this second derivative, Laplace transform of the first derivative here, plus Laplace transform of a y. We have to find the Laplace transform of all the terms. The right hand side, we have to find the Laplace of everything. Okay, so after this, therefore I can go ahead. It means this is a p power 2. Let me use a y bar also, it's a very quick. Minus, means it's a y naught, minus y prime at 0 as well. Minus 3. First derivative here, so it's a p. Minus y naught plus 2. Therefore it's a 1 all over p minus 3. So number 2, we must use the initial conditions given. Y prime is 0 according to the conditions. Therefore y prime is gone. No longer have this is equal to 0. And then we must put together all the terms that are having y bar, right? This term of y bar, there's a y bar here, y bar also here. Just put all of these ones together. So therefore what we get, we are getting y bar is common in these terms, p squared minus 3p plus a 2. All the terms without a y bar, we can put them on other side of equality sign. Means we have a plus y naught. Y naught is a unit, therefore means we just have a plus p here. Minus 3, therefore means it's a plus 3 here. Okay, so this is coming from minus y naught. Y naught is a unit. Minus 1 with this 3 coming in here. So this is a, this is a plus 3, therefore it's a minus 3, okay? Therefore it's a minus 3 here. Okay. Then the next thing that we must do, we must make y bar subject of the equation. Is equal to, so it means it's a 1 over p minus 3, p squared minus 3p plus a 2 p minus 3 p squared plus a 2. Just clean up the space here. Then continue. Okay, so now we were in the stage where we have to find the inverse of the we have to find the inverse of the whole thing, but more work is done on the right hand side. So this it involves the partial fractions. Let us first see if we can get factors of this big bracket. So the p squared minus 3 p plus a 2. Can we find factors of this? Okay, so this we can find factors of the bigger bracket. So the factors here, we can see it's minus 1, minus 2, nice linear factors. Here it's a plus, minus 3, minus 1, minus 2. Right, okay, so this is what we get. So just continue and see what we can do now. So let's put the two terms together. And so when we do that, we can have a p minus 3 minus 1 minus 2 as a common denominator. Therefore divide by dividing this value and this value, it gives you 1 times a 1, means our numerator is a 1 in this situation. Therefore, if a 1, it's a plus. Same division. These two brackets will fall off, give a unit. Therefore, the numerator here will have power 2 of p minus 3. P minus 3 power 2. Okay, so next thing that you can do here is simply just to apply the partial fractions and see what we get from the partial fractions. Because what we want here, we are looking for y, and we have to find the inverse Laplace transform of the right hand side. Again, we are finding the inverse of left and right. It's just that we have to do more on the right hand side. Okay, so this is what we have. Let's first just see what we get from this. Okay, let's see what we get from this fraction here. So the structure of the partial fractions is determined by the denominator. the factors in the denominator, they tell you the structure of each and every term onto your partial fraction. So all of these factors at the bottom, they are linear factors. Therefore means we have a constant on top over, say, the first factor there, constant on top again because it's another linear factor, constant on top, then we put in the last one. Then the next thing that we have to do here, we have to find the values of these a, b, c variables. After that you are done, we come back and we complete the problem. So what are these values? How can we find them? So when finding these values, let us first try to get rid of denominator. So we will do that by multiplying everything with this denominator at the bottom here. Multiply all the terms. So when we do that, we will get a 1 plus, let me open this up. So it's a p squared minus, so this is 3 times 2, it means we have a minus 6 p here, plus a 9, this will help later, is equal to a, so p minus 3 divided by p minus 3, these two will cancel. When the two cancel, we'll be left with p minus 1, p minus 2, plus a b. P minus 1 will cancel, we'll be left with a p minus 3, p minus 2, p minus 2 will cancel again, then we'll be left with a p minus 3, p minus 1, then after this, now let's start with the easier option. Let us try to say let p is equal to some value. What are those values? Those values, for instance, for this problem could be p equal to 2, p equal to 1, p equal to 3. So if we do that, what you will see, for instance, if we say p is equal to 1, it means this c term will be gone because it will multiply with a 0. It will disappear. It means we can get a b by setting p is equal to 1. Just go ahead and get a value of b here. So p is equal to 1 would mean left hand side is a 1 plus, therefore we have a minus 2. P is a 1, right? Okay, let me just do that, then I'll continue in the next step. So what we see that a involve a p minus 1, therefore means there will be 0 here, plus a b. So when p is 1, it means we're having a minus 2 here. 1, it means we have a minus 1 here. C involve a p minus 1, therefore we have a 0 here. So therefore you can see these two variables now are gone. We are left with one variable which you can easily obtain. Therefore means here, so it means 1 plus a 4 is equal to 2b, which therefore implies that b is equal to 5 over 2. Then next we can set p is equal to when p is equal to 2, what do we get? when p is equal to 2, it means b, this b term will suffer, a term will suffer also, they will be 0, these two terms. We can get c. Then let us go ahead and try to get to the c value. So what you will get, therefore, means we're having a 1, means it's a minus 1 here, equal to, therefore, a, involve a p minus 2, therefore this will be 0, involve a p minus 2 again, therefore means we have another 0 here, plus a c, p is 2, means we have a minus 1, p is 2 again, oh, okay, so it's just a unit. So it therefore means left hand side is a 2, as you can see also. We only are left with the variable c here, therefore we can easily obtain our c value. We have a minus c here, which means c is equal to minus 2. Then lastly, we also have an option of letting p is equal to 3. Let p is equal to 3. When we do that, we are getting left hand side will be 1. 3 minus 3 is a 0. Therefore 1 is equal to a. 3 minus 1 means it's a 2. 3 minus 2, oh, means this is just a unit, plus a b. b involve a p minus 3, therefore this is a 0, plus a c, which also is a 0. So again you can see the two terms will suffer, and when that happens, we then get only left with the a variable, which we can easily obtain. Therefore what it means here, it means a is equal to 1 over 2. So it was such an easy partial fraction problem that we have here. So we just have all the values we want. Let us then continue. So what it means here, it therefore means y is equal to inverse Laplace transform of a is a 1 over 2 p minus 3 here. So it's a plus. B is positive also, 5 over 2 p minus 1. C is negative, therefore it's a minus 2 over p minus 2 which easily take us to the conclusion. So therefore what you get here, we are having 1 over 2, then we can use a formula. So when you check the table of transforms in your book, you will therefore find that the transform of 1 over p minus 3, the inverse, because we are looking for the inverse here, this is from e raised to 3t, okay, which therefore means it's our solution here. So we have a plus 5 over 2. I'll just write and erase. 1 over p minus 1, right? Because this is what we have here. We are looking for the transform of this inverse here. That is what we have to find a solution for. Just as this is a solution from this inverse here. Okay. Okay, so therefore, what we have here, let me first get rid of this color here. Okay, so let's continue. So therefore what we have here, now 1 over p minus 1, and this will give us, so this will give us a e raised to t. Then lastly we're having a 2. Then again you have to find the inverse transform of 1 over p minus 2, right? So what is this? So this is simply e raised to 2t. Okay, so this, it gives us the solution to the problem we're trying to solve. Okay, so that will be it. Then this is the end.